Hi, my name is Muhammad Abdi Muhammad Sri and my matrix number is 222422.
Hi, my name is Lim Chuan Kai. My metric number is 225056.
Hi, my name is Tang Kai Jian. My metric number is 223248.
My name is Wana Husna binti Wan Abdul Halim and my metric number is 224142. And all of us are from Group 6. In this video, we will all talk about electronic transducers. This is the content of our video. First, the introduction of transducer. Second content is the objective of our video. The third content is methodology, specifically about strain gauge and thermistor. Last but not least is the conclusion. Introduction. Transducers has the ability to convert one form of energy into another. Transducers become important in revolution industries. By definition, transducers are devices that are capable of transforming different types of physical quantities such as pressure, temperature, or displacement into electrical signals. There are two important parts of transducer, which is sensing element and transduction element. Sensing element can respond to physical sensation, and transduction element converts output of sensing elements into electrical signal. The objective of this video is to give broad understanding of electronic transducers. The second objective is to present specific use cases and examples within each application category. Other than that, it is to summarize key findings and draw conclusions based on information. Last but not least, it is to provide any relevant recommendations for future research or applications.
Then the next, what is transducer? Transducer may be further classified into different categories. For example, resistive, capacitive, inductive, electromagnetic, and ultrasonic transducer. In resistive transducers, resistance changes due to a change in some physical phenomena. The resistive transducer element work on the principle that the resistance of the element is directly proportional to the length of the conductor and inversely proportional to the area of the conductor. These transducers find application in various fields due to their versatility.
Hi, my name is Lim Chuan Kai. Now I'm going to present about one of the applications of the transducer, which is strain gauge. First, let me talk about what is strain gauge. Strain gauge actually is the ratio of the outer length to the starting length, and it is used to compute strain, which is a dimensionless measurement of an object length change. Stretching results in positive strain, whereas compression causes negative strain. By dividing the imparted force by the initial cross-sectional area, we can use it to calculate stress or the internal resisting ability. A metal foil on a flexible substrate detects change in resistance when an object extends or contracts to create a strain gauge. The variations in object surface length is reflected in this shift in resistance. Change in resistance are translated into change in length by the gauge factor, which stands for the strain gauge sensitivity. And then I would like to show the pictures of the strain gauge, which is at the side of the slide. And the blue part is the test specimens, and the gray part is the lead, while the white part is the carriers, and the black part is the metallic grid pattern. Next, I would like to share the working of the strain gauge. The strain gauge is worked through a thin metal wire or foil used to make strain gauge changes resistance in response to compression or stretching. The strain gauge is connected to a circuit that monitors the voltage across an object by passing current through it and is affixed to it using adhesive. The strain gauge changes in length and cross-sectional area as the object deforms in response to the applied force. The resistance of the strain gauge, which is proportionate to the strain which the item experiences, is impacted by this change in geometry. A Wigstone bridge circuit can be used to measure the voltage across the strain gauge, which is a function of the change in resistance, and it is possible to tune the circuit output voltage to show how stress or strain the object is under. And then at the side there, I have put one type of the strain gauge circuit, which named quarter bridge strain gauge circuit, which consists of two strain gauge, and one of the strain gauge is unstressed, and the second strain gauge is stressed. So next, I would like to share some formula involved in the strain gauge, which the first is to calculate the resistance of the strain gauge. The resistance of the strain gauge is equal to the resistivity of the strain gauge, multiply the length of the strain gauge, and then divide by the cross-sectional area of the strain gauge. For the second formula is to calculate the gauge factor of the strain gauge, which is just the per unit change in resistance divided by the per unit change in the length. And then below there is a picture of the strain gauge, which shows that when the length of the strain gauge increase, the diameter of the strain gauge will decrease, which is a relationship in the formula. So next, I would like to share some type of the strain gauge and its application. So the first type of strain gauge is the wire strain gauge. The wire strain gauge can be used to observe the stress and deformations of pipe, which include variations in soil movement, temperature, external pressures, and internal pressure of the pipeline. The second type of strain gauge is the semiconductor strain gauge. This semiconductor strain gauge can be used to measure root pressure. The systolic and diastolic root pressure can be determined by calibrating the strain gauge output voltage. And the third type of strain gauge is the Rosette strain gauge. This type of strain gauge can be used to measure the residual stress in a welded joint junction. Rosette strain gauge can be used to measure the residual stress in the weld and the surrounding regions by applying a procedure known as the hole drilling method. And the fourth type of strain gauge is the foil strain gauge. It can be used to measure the temperature of composite material. Foil strain gauge can be utilized to evaluate the temperature by monitoring the composite material's thermal expansion. Next, I would like to show some picture of each type of strain gauge. And the first is the wire strain gauge, and the second is the semiconductor strain gauge, and the third is the Rosette strain gauge, and the fourth is the foil strain gauge.
Then the next is thermistor. There are two types of thermistor, which is negative temperature coefficient, or say NTC, and positive temperature coefficient, or say PTC. They work on the principle that the temperature coefficient of the thermistor material varies with the temperature. Thermistors are passive components whose resistance changes as the temperature in a system changes. In NTC thermistor, resistance decreases as temperature increases. Then NTC thermistors are commonly used for temperature sensing and measurement. Then the PTC thermistor is the resistance decrease as temperature also decrease. Then the PTC thermistor are often used in application where shell regulation or protection is needed, such as in heating element. Then for the next, NTC and PTC thermistor can mathematically represented as the formula. So when NTC thermistor formula is R equal to R0 E power beta times 1 over T minus 1 over T0. Then where RT is resistant at temperature T, R0 is resistant at temperature T0. T0 is the reference temperature, then the beta is a constant, its value depends on the material. Then the next is PTC thermistor. The formula equal to R0 times 1 plus alpha times T minus T0. Then the R is the resistance at temperature T, then R0 is the resistance of a reference temperature T0. Then the alpha is the temperature coefficient. Then the next, we talk about the application and example of the thermistor. So it actually have two parts, which is domestic and commercial. Domestic, it have microwave or boilers. Thermistor monitor the internal temperature and ensure it does not become too hot. Then the next is digital thermometers. Thermometers often use thermistor as the temperature sensing element as they have a fast response and are accurate. Then the circuit protector. Thermistor controls surge of power and ensure the correct amount is being pushed through devices which are plugged in. Then the next is commercial. It have food and beverage industry. Thermistor can be used to monitor the temperature between the environment of the handling and processing of food to ensure it is kept at the correct temperature. Then the medical application, when precise temperature monitoring is essential, a thermistor is used as it is highly sensitive and will detect if the temperature changes just a tiny amount. They are used for catheters, patient monitoring, and dialysis equipment. Then the last is a vehicle cabin heat. It can to ensure the vehicle stays at the correct temperature.
Hi, my name is Muhammad Adil Masih, and now I'll present the conclusion of this video as my friend just now just present their point. So, in summary, transducers are crucial in many industries, converting energy into electrical signals. This video talks overview of transducers and sensors, explaining their definitions, types, and principles. It highlights the importance of input and output transducer in manufacturing and healthcare. So the methodology of these video sections focus on resistive transducers, particularly strain gauge. Application of strain gauge, such as monitoring stress in pipes or measuring blood pressure, showcase their versatility. We also cover thermistors and other transducer types, explaining their principle and diverse application in domestic and commercial settings. Overall, providing insights into transducer functionalities and application will achieve our objective. It aims to benefit stakeholders, visitors, and enthusiasts by offering a comprehensive analysis of transducers in various fields. So that's all from me. Thank you.